Let's do some 3.2 here, measures of dispersion. So we've got more vocab because that's how we roll in statistics, right? So we've got a lot of vocab to go through today, but we are also going to talk about standard deviation. So I'm planting the seed of those words because that is major, major, major. Okay, so let's do it up right now. So the measures of dispersion. Dispersion is the degree to which the data are spread out. So how dispersed is the data, right? Remember we said mathematicians aren't creative. Whatever you say is kind of how it rolls. So we've got this big, huge table here about University A and University B. These represent IQ scores of random sample of 100 students from two different schools. For each school, we want to compute the mean, which we've learned at, and draw a histogram, which we're going to have Minitab do for us. All right, using the lower class limit of 55 for the first class and the class width of 15. So that it ends up being the same. Even though we have two separate pieces of data, whenever we set this, then it works. And then we're going to comment on the results. All right, so what we are looking at here, and so how do you find a mean? Yep, you add it all up and divide it by the total. So because this is a whopper piece of data and we already know how to find a mean because that was our last section, what I want to do right now is more talk about, instead of doing the computation, what the computation means. All right, so because of that, here we know that the mean of both universities is 100. Oh, handy, right? And it asks us to draw a histogram. I'm trying to make this as big as possible here. And it asked us to draw a histogram. Remember, the lower limit is 55 with a class of 15, like the width of 15. So I'm going to have to make this even bigger. I can't see that, so I know you can't either. Check this out. I know it's a little blurry just because it was a screenshot and I brought it in here, but you can still get the concept that goes with it, right? Look at what's happening here. Here's my mean of 100. Here is my mean of 100. Look at this data. Look at this data. You see what just happened there? Let me do that again. Look at this data. Look at this data. Ah, that's dispersion. That's dispersion. How spread out is my data? That's what we want to look for. Look at what's going on here. My low number is a 55. My high number here is 145. I've got the same because that's what it asks us to do, right? The low is 55, and then that's set up. But look at what's happening. Is there anything down here in this range? No. Is there stuff over here? Yes. Is there anything up here in this range? No. Is there stuff over here? Yes. Which this just tells me that this data is more spread out. From University A is more spread out, where this is a tight, right? Tight data. Is tight, right? Real close to that middle mean situation, all right? That's dispersion. It's a greater dispersion to have your data spread out so much like you have over here with University A. It is smaller dispersion whenever they're all really close values together. And that's what we're looking at there. Okay, that's dispersion. Okay, well, looks like whenever I wrote on this, I wasn't paying attention. Let me write this out here just a tad bit better. So this is this. I do want you to have this in there, that this is just spread out data. Oh my goodness. Between my bad handwriting and my pencil slipping around on me, it's a bad news bears here, right? Spread out data, and then the majority of data right in there is tight, so that'll be fine because we don't need much space here. All right, something else that can help here is you want to say, what is your range? Your range is from the low to the high. So typically whenever we're talking about a range of data, we do that subtraction. Not typically, that is what we're talking about here. When we talk about range, it's a capital R. It's the largest data value minus the smallest data value. So, moral of that story, what you're really looking at here is that this is going to be the big minus the small. And then that number will give you your range. So how far are we out there? That's what we want to know. All right. Okay. So we are going to look at the same data. I'm going to try to make this a little bit bigger here. We're going to look at the same data that we did in the last section on these test scores. And we want to compute the range of these test scores. All right. Okay. So big minus small. That's what we're looking for. The highest score minus the lowest score. So my range here, what's the highest score that we got? Oh, looks like old Justine here got a 94. Who had the lowest score? Jennifer? So what I'm seeing here with the 62. And then that would be your range. So my range is 94 minus 62, which gives me a range of 32%. All right? That's your range. That's what I'm looking for there with that range. Cool, right? All right.